Hello, today we are going to be looking at an overview of ClearCalcs on concrete beam calculators in Australian standards. So let's open up a calculation of rectangular concrete beam. At the top, we can see that we are designing to AS 3600 2018 at minimum number 2, and the design assumptions are listed here. We take a look. Then we can input our key properties to design our beam. ClearCalcs currently support the rectangular beam, but the common T-beam is under developing and will be released in a very short time. Here we can input our geometry dimensions, the total depth, the breadth of our cross-section, and the total length of our beam. We can select the concrete strength and type from our database. For now, we have the concrete with a normal weight. The density is 2400 kilonewton per meter square. Like other calculators, ClearCalcs is always developing our database. If you can't find your design material or you request a new section of features, you can just simply click the help button and request. Then we'll have them shortly. Like all of our beam calculators, we can input an unlimited number of supports. Afterwards, we can customize our steel reinforcement in the beam. As common concrete designs, ClearCalcs designs the reinforcement at the positive moment region and the negative moment region separately. For example, if we add a support at the middle of our beam, we scroll down and we get our negative moment region. We can select the reinforcement size and type, again from our database, and we can define the numbers of reinforcement bars. Then spacing is automatically calculated by the code clause 8.1.9. Like in all the calculators in ClearCalcs, if we are not sure about anything, just click on the label and we can see the descriptions and the references. Then we specify our bottom cover and we can see the depth to the bottom steel and the total area of bottom steel are automatically calculated. Afterwards, we can decide whether we need top reinforcement for our section in positive moment region. Like bottom reinforcement, we can design reinforcement at the top, following the same procedure. Afterwards, we can design shear reinforcement, so-called shear fitment, and add our supports. This section is used to calculate the steel components of the shear capacity. Same procedure, select the type, define the numbers of legs per fitment bundle. For a typical standard, fitment will have 2 legs, and define the spacing, and we have 90 degrees for perpendicular fitment. ClearCalcs also check the maximum fitment spacing to satisfy requirements in the code. Similarly, we can design the reinforcement at the negative moment region. Like all of our beam calculators, we can also include a limited number of loads in various locations, and we can also link it to other sheets that we may have designed using ClearCalcs. The design criteria will allow us to specify the limits for the deflection. Scrolling down, like all of ClearCalcs calculators, we can check all the intermediate steps and values, like member properties, load combinations, also the intermediate steps used to calculate the flexural analysis. We can find our neutral axis, the Ku value. Another example is that we can see how we determine our capacity factor in bending, which is dependent on strain at the extreme tension steel. That's where the values come from. Scrolling down, we can check the shear analysis as what we input for our fitments. We can check our shrinkage and creep analysis. For the deflection, this is indicated in the code for concrete in the serviceability requirements. We can see all the calculations for deflections like short-term and long-term. ClearCalcs used a prescriptive method to do the stability analysis. We need to specify the L1, the distance between the restraints. We open it up. If we have a simply supported or continuous beam, this L1 value over the effective compression width will not exceed the lesser value of either 180 mm times the beam breadth over the total depth or 60 mm. Similarly, we need to define the maximum length if we have a cantilever beam for the stability. Like all ClearCalcs calculations, our computed results are always updated in real time and located at the top right of the page and the summary. We can also make use of the traffic light system to see whether our design capacity is passing. And below, there are dynamic diagrams that shows the reactions as well as the graphic load combinations.